Right, this is a video for AP Calculus reviewing some of the problems we did in class on solving limits, finding limits analytically. This might need to be a part 1 video depending on how far I can get. So the first question that folks had was about number 3, which was kind of a challenging one. So the limit as x approaches 1 of x squared minus 5x divided by x minus 1. Okay, so when we substitute 1 in for x, we get a 0 denominator. So we know that we need to do something else to find the limits. So what we talked about yesterday was try and factor. So we factor, there's the greatest common factor of x in the numerator. X times x minus 5 is the factorization of that expression in the numerator. Now, what we notice is that nothing divides out to 1. Right? So what that means is that x equals 1 is a vertical asymptote. Okay, so the limit will either be infinity or negative infinity, some combination of that. So what we need to do, or the way I like to think about it, is to test the limit as x approaches 1 from the left and from the right. So think about a number that is just a little bit smaller than 1, something like 0.9999. And conceptually substitute that in for x. So something a little less than 1 is what I'm noting as 1 with that negative in the superscript there. So something just a little bit less than 1 times something just a little bit less than 1 minus 5 divided by something just a little bit less than 1 minus 1. Okay, will that end up approaching positive infinity or negative infinity? So we're going to look at the signs, or the whether this expression will become positive or negative, will be positive or negative. So something just a little bit less than 1 is positive, right? Something like 0.9999, that's a positive number. Something just a little bit less than 1 minus 5 is negative. And then something a little bit less than 1 minus 1 will be a a negative number very close to 0. Okay, positive times negative, negative. Negative, negative, negative divided by negative, positive, right? So what that means is that the limit as x approaches 1 from the left is positive infinity. We're going to do the same thing from the right. So imagine a number that's a little bit larger than 1, just a little bit larger than 1. So for example, 1.0001, right? So that number, we would substitute that in for x as a concept. So something a little bit larger than 1 times something a little bit larger than 1 minus 5 divided by something a little bit larger than 1 minus 1, okay? So how's that going to look when you simplify? This is going to be a negative number, right? Positive number. And then here, something a little bit bigger than 1 minus 1 will actually be positive. It's going to be a very small number, but it'll be positive. So positive times negative is negative, negative divided by positive is negative. So as x approaches 1 from the right, you're going to be approaching negative infinity, okay? So we're going to say the limit does not exist. So that's that on number 3. Number 5, we can do, and number 5 was the limit as x approaches 0 of 3x divided by the sine of x. All right, so this requires you to refer to some of our special limit rules. But first, let's remember the first one. So one of the rules about limits is that this is equivalent to this, 3 times the limit as x approaches 0 of x over sine of x. Okay, so you can actually, that 3 can actually go outside of the limit. We're still multiplying it, okay? And then another thing that we need to refer to is that, remember that the limit as x approaches 0 of sine of x over x is a special limit and it approaches 1. That was one of the special limits on the slide in that video I had you watch. This is one of our special trig limits. Okay, and again, I'm really going to encourage you to watch that video I posted on proving it because it is a very cool proof, but that's the limit. So if the limit of sine of x over x is 1, as x approaches 0 of sine of x over x is 1, then the limit as x approaches 0 of x over sine of x also has to be 1, right? So the way we can simplify this is that it is 3 times 1, or 3. Right. So that's that on number 5. Okay, I'm going to go ahead and do number 8. So number 8 was the limit as x approaches 7 of the square root of x plus 9 minus 4 divided by square root of, oh, no, not square root, just, let me write that again. The limit as x approaches 7, the square root of x plus 9 minus 4 divided by x minus 7, no square root in the denominator. Okay. Okay, so this is one where if you substitute 7 in, you're going to get a 0 denominator. There's nothing really to factor, right? But what we can do is multiply by the conjugate of square root of x plus 9 minus 4. So we can multiply the numerator and the denominator by x plus 9, square root of x plus 9 plus 4, divided by square root of x plus 9 plus 4, right? That's okay, because we're just multiplying by a fancy form of 1. Okay, so that's totally okay. And then if we go ahead and distribute in the numerator, right, that's going to be, that whole entire numerator is going to simplify to x plus 9 minus 16. And then in the denominator, we have all of this, x minus 7 times square root of x plus 9 plus 4. Okay. If we simplify this numerator and combine like terms, we're going to get x minus 7. Okay, and then I'm going to rewrite everything that we had in the denominator, x plus 9 plus 4. Okay, now what's interesting, right, is these two terms are multiplied together, right? This is x minus 7 times square root of x plus 9 plus 4. So what can actually happen, what you can do is divide out x minus 7 divided by x minus 7. So this is going to be the limit as x approaches 7 of 1 over square root of x plus 9. Let me extend that, plus 4, okay, because basically we divided these out, okay. Now, it looks like if we substitute 7 in, we will not get a 0 denominator. So let's go ahead and do that. We're going to substitute 7 in and wrap this up. So it is 1 divided by square root of 7 plus 9 plus 4, which is 1 over square root of 16 plus 4. And we're taking principal values because we're dealing with functions. So that's just, we're going to just have that be positive 4 plus 4, or 1 over 8. Okay. So that's an example of how you would do a conjugate. And 13 looks pretty similar to that. So if you were having a hard time with 13, 11 should help you with that. All right. Let's look at okay, let's look at number 18. So number 18 is another one that was requested, and that's actually an introductory concept of what we're doing with what we'll do in unit 2. So it's the limit as h approaches 0 of 5 times square root of x plus h minus 5 square root of x divided by h. Okay, so we can see that what's going to happen, again, if we substitute h in, we're going to have a 0 denominator. Okay, but what we could do, again, this is just kind of what I've been teaching you, and what you can do is multiply it again by the conjugate. So we'll try 5 square root of x plus h plus 5 root x divided by 5 square root of x plus h plus 5 times root x. Okay, so again, we're just doing that conjugate. Okay, so now we have the limit as h approaches 0 of 25 x plus h minus 25x divided by h times 5 root x plus h plus 5 root x. Okay. And now, just as before, we're going to simplify the numerator. So that'll be, again, I'm bringing this down. I can go ahead and distribute that 25 to both of these terms, and we'll see what happens. So we have 25x plus 25h minus 25x. And then we have h. I'm not doing anything with the denominator. I'm just copying it right down. Okay. All right, so as we see, we do have some like terms in the numerator, 25x minus 25x. So those are going to subtract to 0. And that leaves us with 25h divided by h times this original conjugate. Okay, so what I can do now is say, okay, I can also divide the h's out, right? So now what I'm going to be left with after I do all of that is this is the limit as h approaches 0 of 25 divided by 5 times root x plus h plus 5 root x. Okay. There's some more stuff I can do to simplify, and I'm going to go ahead and do it because this is a video. We're not rushed for time. I'm going to factor out the 5 in the denominator and see if I can get this to be a little more elegant. So that's going to be 5 root x plus h plus root x, right? So all I did was factor the 5 out there. And now this is going to divide out to 5 over 1. Okay, so now it looks like I am safe. I can actually substitute 0 and not end up with a 0 denominator. So let's try that. So now I have 5 divided by square root of x plus 0 plus square root of x. Okay, so that's going to be 5 over square root of x plus square root of x, or 5 over 2 root x. Okay, so you can write it like that, or if you don't like radicals in the denominator, you could write it as 5 over 2. You could write it as maybe x to the negative 1/2 if you like it that, if you prefer it that way. But really, once you're here, you've done the calculus. Okay, I'm going to stop recording and I'm going to try and do 33 in part 2. Okay, so as always, let me know if you all have questions. Thank you for watching, and I will see you in the next video.